Have you ever wondered how AI has the ability to create something from nothing? Welcome to the mesmerizing realm of artificial intelligence, where the boundary between reality and virtuality blurs, and creativity takes on a completely new dimension. In the vast universe of AI, we encounter a multitude of stars, each representing a different concept. Some are well known, like machine learning and neural networks, while others, though equally fascinating, are yet to be fully discovered by the mainstream. One such star is the concept of AI as a tool for creation. Just imagine a machine creating art, composing music, or even designing fashion styles. Sounds like a science fiction, doesn't it? But this is the reality we live in today. AI is no longer just a tool for analysis or prediction, but it has evolved into a tool for creation as well. This creative capability of AI is not a random phenomenon, but a result of a specific type of neural network architecture known as Generative Adversarial Networks, or GANs in short. They are the master artists, musicians, and designers in the AI world, creating masterpieces out of thin air. GANs are the magic behind those realistic deepfake videos or the stunning AI-generated paintings that you might have come across. They are the unsung heroes behind AI's creative prowess, working silently in the background, creating, innovating, and transforming the way we perceive creativity. But how do these GANs work? How do they create something out of nothing? How do they learn to create, and how do they improve their creations? These are some of the questions that we will be exploring in this journey. So fasten your seatbelts as we embark on this exciting ride into the creative world of AI. We will be delving into the intricate workings of GANs, unraveling the mysteries of their creativity, and understanding how they are transforming the landscape of AI. Let's dive deeper into the world of Generative Adversarial Networks, or GANs, to understand this better. GANs, or Generative Adversarial Networks, represent a class of AI algorithms used in unsupervised machine learning. These algorithms are a bit like a forger and a detective locked in a constant battle. The forger, known as the generator, creates fake items. The detective or discriminator tries to distinguish the real from the fake. Through this process, GANs are able to learn and generate new, unique data on their own. They've become a cornerstone in the world of AI, used across a range of applications. They're behind the creation of those incredibly realistic deepfake videos you may have seen, or those AI-generated paintings selling for thousands. They're used in video game development, healthcare, and even astronomy. But don't be fooled by the complexity. At their core, GANs are about two things: creation and discrimination, working together in harmony to produce something new, unique, and often astonishingly realistic. So how do these GANs work? Let's explore. GANs consist of two main components: the generator and the discriminator. Now let's delve into these intriguing parts of the GAN mechanism. Imagine the generator as an ambitious artist, whose sole mission is to create the most convincing counterfeit paintings. The generator starts with random noise, akin to an artist starting with a blank canvas. It then applies layer upon layer of transformations, akin to the artist's strokes, until it produces an image. But here's the catch. The generator has never seen a real painting. It's like an artist who has to create a masterpiece without ever having seen one. On the other hand, the discriminator is like an art critic. Its job is to distinguish between the real paintings and the counterfeit ones produced by the generator. The discriminator scrutinizes each image it receives, attempting to determine whether it's an original or a forgery. So, in our analogy, the generator and discriminator are in a constant game of cat and mouse. The generator strives to create counterfeits so convincing that the discriminator can't tell them apart from the originals. The discriminator, on the other hand, tries to become so adept at spotting forgeries that it can't be fooled. Over time, through this continuous interaction, both the generator and the discriminator get better at their jobs. The generator learns to produce increasingly convincing counterfeits. The discriminator becomes more and more skilled at spotting the differences between real and generated images. This, in essence, is the relationship between the generator and the discriminator in a GAN. A fascinating dance, isn't it? The generator creates, the discriminator critiques, and together they push each other to improve. It's a dynamic that's unique to GANs, and it's what allows them to create such impressive results. But remember, this is just an analogy. In reality, the generator and discriminator are complex algorithms working on numerical data. But by thinking of them as an artist and critic, we can gain a deeper understanding of how they work together in a GAN. The interaction between these two components is what makes GANs truly interesting. The functioning of GANs can be likened to a game of cat and mouse. Imagine a world where the cat represents the discriminator and the mouse, the generator. The cat's goal is to catch the mouse, whereas the mouse's aim is to avoid getting caught. In the realm of GANs, this chase represents the core process that enables the creation of impressive, realistic outputs. So let's break down this process, step by step. First, the generator creates a sample. This is the mouse making its first move. It's important to remember that at the start, the generator doesn't really know what it's doing. It's like a mouse blindly running in a maze, creating samples that are random and far from the desired output. And this is where the discriminator, our cat, steps in. The discriminator's task is to distinguish between the real and the fake, the genuine and the generated. It's given a mixture of real samples from a training dataset and the generator's fakes. The discriminator then makes its decision, classifying each sample as real or fake. It's a savvy cat, learning from each encounter and becoming better at distinguishing the real from the fake. The generator, on the other hand, is not sitting idle. It's learning from the discriminator's decisions. It takes note of the samples that were classified as fake and tries to understand why. It uses this information to improve its next round of samples. Like our mouse, it's learning the maze, figuring out the turns, and getting better at evading the cat. This process repeats over and over, with both the generator and the discriminator continually learning and improving. The generator strives to create samples so good that the discriminator can't tell they're not from the real dataset. The discriminator, in turn, is constantly honing its ability to distinguish between real and fake. And the result? Over time, the generator starts producing samples that are incredibly similar to the ones in the training dataset. The mouse has learned the maze so well that it can now run through it blindfolded. The discriminator, despite its best efforts, struggles to tell the difference between the real and the generated. This is the essence of GANs, a constant dance between two components, each pushing the other to improve. It's a fascinating interplay of learning and adaptation, a game where both players evolve together. It's a process that's both complex and elegant, much like the dance between a cat and a mouse. And it's this dance, this iterative process of learning and improving, that allows GANs to create new, original content. It's what enables them to generate images that are so realistic that you'd be hard-pressed to tell them apart from the real thing. This complex dance between the generator and the discriminator is what enables GANs to create new, original content. So the next time you see a stunning piece of AI-generated art or a realistic deepfake video, remember the game of cat and mouse that made it possible. The potential applications of GANs are vast and far-reaching. These networks are not just theoretical constructs, they are practical tools with a multitude of uses across various fields. Let's dive into some of these exciting applications. In the realm of image generation, GANs have shown an uncanny ability to create highly realistic images. From dazzling landscapes to detailed portraits, these networks can conjure up images that are almost indistinguishable from real-life photos. They can even create new, unique faces that don't belong to any existing person, and yet look convincingly real. But it's not just visual art where GANs shine. They're also making waves in the world of music. By learning the patterns and structures in different genres of music, GANs can generate entirely new compositions, pushing the boundaries of creativity and opening up a whole new frontier for musical exploration. And let's not forget about their use in data augmentation. In fields like healthcare, where data is often scarce or sensitive, GANs can generate synthetic data that mimics the real thing. This allows researchers to train more robust models without compromising patient privacy. Even in video games, GANs are making their mark. They're used to generate dynamic and immersive environments, creating worlds that evolve and respond to the player's actions. This not only enhances the gaming experience, but also reduces the workload for game developers. Beyond these, GANs are being used in numerous other fields, from fashion design, where they generate new clothing styles, to astrophysics, where they help in the simulation of dark matter. But perhaps the most exciting thing about GANs is their potential for future applications. As this technology continues to evolve, who knows what new doors it will open? We're just scratching the surface of what's possible with GANs. The power of GANs is truly remarkable, isn't it? Their ability to learn, create, and innovate opens up a world of possibilities, making them one of the most transformative tools in the realm of artificial intelligence. However, like all powerful tools, GANs come with their own set of challenges and controversies. These challenges start right at the heart of the technology. Training a GAN to perfection is a balancing act. It's like teaching two children to play chess against each other. If one becomes too good, the other loses interest. Similarly, if the generator is too good, the discriminator might fail to tell the difference between real and generated data, leading to a failure in learning. Next up, we have the infamous mode collapse issue. This is when a GAN starts to generate the same output over and over again, no matter what the input is. It's like a broken record that only plays one song. This limits the diversity of results and defeats the purpose of a GAN. Now let's talk about the elephant in the room, the potential for misuse. GANs can create realistic images, audio, and even video. This opens the door to a dark world of deepfakes where the line between reality and fabrication blurs. The ethical implications of this are vast and complex. There's also the issue of copyright infringement. If a GAN creates an artwork that closely resembles an existing piece, who owns the rights? The original artist, the GAN, or the person who trained the GAN? These are questions that our current legal framework struggles to answer. GANs also have a voracious appetite for data, and the more diverse the data, the better. But in a world where privacy concerns are escalating, obtaining such data can be a challenge. Lastly, the environmental impact of training GANs cannot be overlooked. These models require powerful hardware and consume a significant amount of energy, contributing to carbon emissions. It's clear that while GANs hold immense potential, they also raise important questions that we must address. So, we've taken a journey through the fascinating world of GANs. These intriguing models, with their dueling components, the generator and the discriminator, have truly revolutionized the field of artificial intelligence. We've seen how they operate, with the generator creating new, synthetic data, and the discriminator working hard to distinguish between real and generated data. It's an ongoing dance of deception and detection that's as captivating as it is complex. We've also delved into the immense power of these networks. They have the potential to create realistic images, generate human-like text, and even design new pharmaceutical drugs. From arts to healthcare, GANs are making their mark, transforming how we understand and interact with the world around us. But it's not all smooth sailing. We've touched on the challenges and controversies surrounding GANs. The risk of generating misleading or harmful content, the difficulties in training these networks, and the ethical considerations they raise. These are all issues we need to grapple with in our quest to harness the power of GANs. Yet, with every challenge comes an opportunity. The roadblocks we face in the realm of GANs are pushing us to innovate, to think critically, and to devise solutions that not only enhance the performance of these networks, but also ensure their responsible usage. We're living in an era of unprecedented technological advancement. The world of artificial intelligence, with GANs at its helm, is evolving at a breakneck speed. Each day brings new discoveries, fresh insights, and exciting breakthroughs that are reshaping our understanding of what's possible. As we wrap up our exploration of GANs, remember this: the journey is far from over. The field is ripe with opportunities for research, development, and innovation. As we continue to explore the vast potential of GANs, one thing is certain: the future of AI is exciting and full of possibilities.